Look at this planet. Every person you have ever known, every historical event you've read about, and every single lifetime in human history has happened right here. Because it's the only major celestial body we can easily see at night, our intuition tells us the moon is close by. It feels like a physical neighbor sitting just across the street. But that sense of scale is an illusion. The empty space between Earth and the moon is actually so wide that you could take 30 identical Earths and line them up end to end perfectly in the gap. If you could somehow point a car straight up into the sky and drive at a highway speed of 100 kilometers per hour, it would take 160 straight days of driving just to reach the lunar surface. Once you finally arrived, looking back, our massive home planet would appear as nothing more than a bright marble hanging in the black sky. If crossing the distance to our absolute closest physical neighbor takes months at highway speeds, measuring the deep void of space is going to require a completely different set of rules. We see this breakdown clearly when we look just one planet further, toward Mars. Here, everyday earthly measurements like the kilometer become practically useless. Depending on our orbits, Mars can sit up to 425 million kilometers away. Even a beam of light moving at maximum physical speed takes 20 minutes to cross that gap, meaning a simple hello and a reply would take nearly an hour. This map of the inner solar system shows why astronomers had to invent a new metric. To measure these huge gaps, they created the astronomical unit, or AU. 1 AU is exactly the distance between the Earth and the Sun. This brings us to Voyager 1. Launched decades ago, it is the farthest physical object humanity has ever sent into the cosmos. Right now, that probe is flying through space at 138 AU away from Earth, meaning it is 138 times further from us than the Sun is. When Voyager turned its camera around to photograph Earth from that distance, our entire world was reduced to a single pale blue pixel caught in a beam of scattered sunlight. Voyager is traveling at roughly 17 kilometers per second, yet even at that incredible speed, it will take another 30,000 years just for this probe to fully exit our solar neighborhood. The moment we leave the boundaries of our solar system, even the astronomical unit breaks down. The gaps become so immense that we have to measure by the time it takes light to travel in a single Earth year. 1 light year covers over 9 trillion kilometers. Our absolute closest neighboring star, Proxima Centauri, sits 4.2 light-years away. At Voyager's current speed, reaching it would take 70,000 years. This map shows the fill structure of our Milky Way galaxy, a spiral disk measuring 100,000 light-years from edge to edge. Within this structure sit approximately 100 billion individual stars and planets. That microscopic yellow dot marks the absolute maximum distance our broadcast radio signals have ever traveled. If any intelligent life exists outside that tiny bubble, they are completely deaf to our existence. Stepping outside the Milky Way, we enter the local group. Here, entire galaxies containing billions of stars are treated as single collection points, scattered across a volume 10 million light-years wide. But the local group is just an offshoot of the Virgo supercluster, stretching 110 million light-years across. And Virgo itself is completely swallowed by the Laniakea supercluster, a massive web of 100,000 galaxies spanning 520 million light-years. At this scale, linear distance has entirely surrendered to volume. Massive galaxy clusters that contain trillions of worlds appear as nothing more than dust suspended in the dark. Pulling all the way out, we reach the edge of the observable universe. This sphere measures 93 billion light-years in diameter and contains at least 200 billion separate galaxies. But this boundary is not a physical wall, it is simply a limit of time. We can only see as far as light has had time to travel to our observatories and telescopes over the history of the cosmos. Because the universe is expanding outward faster than the speed of light, vast regions beyond this edge are permanently hidden. Their light will simply never be able to catch up to us. According to calculations in cosmic inflation theory, the physical universe extending past our visual barrier could be 150 sextillion times larger than everything we can currently observe. This animated model shows what that math looks like in physical terms. If the entire observable universe, all 200 billion visible galaxies, were compressed to the size of a standard football, the unobservable universe around it would be the size of the planet Earth. Realizing we live inside a microscopic cosmic football might feel isolating at first. But looking out into the dark doesn't mean we should feel small. It means we have only just opened our eyes to a massive frontier with endless discoveries waiting ahead.